Hello everyone, welcome back to the channel. So today we would be discussing the next Codeforces contest, which is the Codeforces Round 1999. In this I was able to solve ABC, so let's discuss the problem one by one. And guys, there is a small question and surprise at the end of this video, so please stick till the last of this video. Yeah, so let's start. So if we see the first problem, so the first problem was very easy. Like in this contest, A and B were the very easy problem. C was quite a tough and a challenging problem. I was also like taken a lot of time to solve this problem. So let's discuss with the A. So A is saying that every A of I is between 1 and 2n, and for every element you need to find, okay, yeah, it was a very easy problem. So if we discuss it, so what the problem statement was saying is that what we have is we are having given with an array, like we have to make an array, like, okay, and we are given with the value n, right? What we have to do is we have to choose the elements a of I, a of 1, a of 2 till a of n. We need to output an array such that every pair which is a of 1, a of 2, a of 3 till a of n, and a of, then we add the adjacent elements. These all kind of pairs should be distinct from each other, right? So let me give you an example. So let's suppose n is equals to 4, and if we have taken the arrays 1, 2, 3 and 4, right? So if I start making the pairs, it would be 1, 2, 3, 4. Till here it would be distinct, but when I add 1 and 2, it would become 3. So this 3 is actually matching here. So like this cannot be the possible combination of the array. So we need to return some of the combination of an array such that this particular satisfy the condition. So it was very easy. So in terms of logic, if I say, try to think that a of I, if we put a of I as even or odd, any of its numbers, right? If I put a of I as an odd number, then adding two odd numbers, a of I plus a of I plus 1, to adding two odd numbers would actually eventually give me an even number, right? And if they both are distinct, then the sum would also even would also be distinct. So this is what we would be doing. We would be printing all of the elements in 1 to 2n. All of the odd elements are taken as an array elements. So if we talk about this particular here, so these all would be odd, which would be distinct from each other, and these all would be even, and they would all be distinct from each other, and they would all be distinct from themselves as well. So this is how you will be solving this problem. So if I show you the code, so what I've done is I've taken from 1 to 2n. If its element is odd, I'll just print it, and so that's the answer. So that's how the problem A is. Quite an easy, and I would say very easy in terms of. Okay, so now let's jump to the problem B. So what the problem B is saying, so you are given, choose a positive integer k, and there's a subsequence, okay, and we need to do this, and we need to make it a non-decreasing. Oh, okay. So problem B was actually was also easy. Like it was kind of a very greedy kind of a problem. So if we say what the problem statement is saying, that we are given with an array, right? We are given with this array, and from this array we need to choose a subsequence B. Like let's suppose a subsequence is actually, you know about the subsequence, right? It is a sequence where the elements are being picked in a random order, right? Not in a contiguous manner. That would actually be a substring or a. So in this, the elements are being picked in a non-contiguous manner. So let's suppose we pick this and this element, example of an array, and we need to add all of them by k, so that we make this particular array as non-decreasing it, that a of I plus 1 should be greater than equal to a of I. Like this is the case for non-decreasing, okay. And there is a case that this operation can only be performed once, right? So this could only be performed once. So if we jump to the logic part of it, like how do we actually approach this problem? Okay, so if we see the logic of this logic, so in this problem, if we have an array, right, if we have this particular array, and let's suppose this particular a of I, if we talk about any a of I, let's suppose this, if this a of I, if this a of I is actually less than a of I plus 1, then do we need to do anything? No, right? We don't need to do anything, because it would be then following this particular principle, and it's already in increasing order, so we won't be doing anything. But if the cases are different, if a of I is actually greater than a of I plus 1, Then what we would have actually done to make it make it increasing is, sorry, make it non-decreasing, or we could say increasing, is that we could make this a of I could be minimum equal to a of I plus 1, sorry, a of I minus 1. Like this could be the minimum least possible value for this to actually reach, right? So what we will actually be doing is we would be going and find a value k for which a of I minus a of I plus 1, for which a of I is less than a of I plus 1. Sorry, a of I is greater than a of I plus 1. Let me write this. Yeah. So we'll be find for each k, and we will go and find for the maximum of this, right? So we'll go and find for the maximum k which would be possible, right? And out of those all maximum possible k's that we have actually reached, what we will be doing is we will be then finding and checking whether the particular k is like working or like fulfilling our conditions or not. So let me give you the logic as well. So what we will actually doing is, so we would be what we will be finding is, so k would something be like max of all a of I greater than a of I plus 1, right? And it would be this. Okay, now once we have got this, but the reason to take max is actually to what if it's the maximum possible gap between two numbers, right? If I'm talking about this and this is the maximum possible gap, then I need at least this much of k to fill this particular gap, right? To make it non-decreasing, I need at least this much of k, so that's why I'm taking max over here. Now we would be using this particular k, right? So what we'll be using is that if we need at least this k, right? So we would be checking if the answer could be possible with this k or not. So what we would actually be checking is that if a of I is greater than equal to your current, right? If it's already greater than equal to your current, then you will simply update your current. Here current is actually defined as your previous element. Current is equals to fi, like the maximum previous element that you have achieved right now. If it's less, what we will be doing is, this is the if condition, right? Else if it would be like a of I plus k is greater than equal to the current, then update your current, which is equals to a of I plus k. Else we would be saying that the case would not be like the possible flag, or you taken a flag value would be false instead, and you can simply break from here. I hope you would be you are able to see what I'm trying to tell, that go and find the value of k, the maximum possible value of k, and try to use this particular value and see whether the condition, whether the array that we want to achieve is possible or not. So let me show you the code as well. So here what I've done is I've gone and checked for each of I, a of I is greater than a of I plus 1, and I find the maximum k, and for that if k is equal to 0, I would know that it would be already an increasing array, so it would simply be yes. Else what I'm doing is I'm going and checking if this particular element is already greater than the current element, then it's actually an increasing condition, so I'll simply update my current. Else what I'll be doing, I'll try to update this value with a k value, and if I'll say whether it's fulfilling the condition. If it's fulfilling, then I'll update my current. Else if it's not fulfilling, then I know that my flag should be false, and it would simply break from here. So this is how the B problem can be solved. Now let's jump to the C problem. So this is actually a good problem, I would say, a much more difficult problem to solve, but yeah, sure, we will be seeing how we can actually optimize this. Like this problem was not tough in terms of logical part, but in terms of coding part it was a bit challenging, because I have also faced runtime error and a TLE as well, and actually this TLE actually took me the time to reduce it, right? So let's see what the problem is saying. Okay, so the problem is saying that we are choosing an element, and if the element is even, we can divide it by 2. If the element is odd, we can increase it by 1. Okay, so what the question was saying, that we are given with an array, and for each element. If a of I is even, I'll simply do a of I by 2, and if it's odd, I'll simply do a of I plus 1, right? And we need to boil down every element such that this particular every element boil down to a same element, right? Same element. Okay, so the first thing that actually comes to our mind is dp, right? We all thought of that we could use dp in this problem, but dp is not the good solution over here, like in terms of what I thought, because you don't know any start value or you don't know any end value. Just what you can do is you can assume a start value and find how many steps you can reach a particular value, but that won't be sufficient enough to tell you that how would you be actually minimizing the number of operations and to reach a particular value. Like how would you be knowing that whether they are reaching at a particular value or not? Okay, so what the logic we would be using over here is, so the logic what I am thinking of is, I have taken a of I, right, and I have tracked this particular path. Let's suppose a of I is even right now. Let's suppose it would have been even. Then what it had gone to a of I by 2. It would have gone to a of I by 4. Now let's suppose this particular value becomes odd, right? Then it would have gone to a of I by 4 plus 1. Now let's suppose this value is even, then it would still have done by 2, right? So eventually if you see, this would all comes and boils down to a value either 1 or 2. Like it would either come at 1 or either come at 2, and once it has come to either 1 or 2, it would start repeating from here. It would start repeating. Like if I tell you, if for 1 I would simply do plus 1, I'll reach 2, and from 2 I'll 1, then it would start repeating over here. Same for 2 to 1, then 1 2 again 2, then 2 to 1. So this would start repeating. So what we can say is that for every a of I, it would eventually reduce to either 1 or 2, right? So this is our safe case. Like this is a safe case in terms of that. Here, so I can for sure say that they would be converged at either 1 or 2. Like I could make them to converge at 1 or 2, and I could count the steps, right? But now the question is a bit challenging in terms of, we need to find some larger value greater than 1 or 2, where the steps are minimum and they all are coinciding at this particular step, like this particular value. So now with this you might have come up with an intuition. You already got an intuition. What you would be doing is, for each a of I, we would be storing its path, right? So we would be storing its path, out of which path this particular element is going through, right? So once we have actually got this path, so okay, so what we would actually be doing is, we would maintaining a score kind of a map, scoreboard you can say, right? And scoreboard would be having maintaining two particular things. So let me define that. So first we will be defining a reached count. What does this reach count means? That how many numbers from array visited a particular value v. Okay, let's suppose this particular value is defined as v, like, right? And what we will be defining is total steps. So, and this would be telling us total operations, not be how. So it would be total operations, total ops to get at v, right? So how many numbers to go for to visit v would actually be, we would be checking the count, and here is the total number of operations, right? Okay, so if we start from a particular value, now let's trace the path. Okay, so now let's trace the path. Now what we will be doing is, let's suppose we start at a particular value x. So what the rule actually says is, if x is even, simply do x by 2, and if x is odd, simply do x plus 1, right? And we would be update this particular operation into our hash map or scoreboard kind of a hash map you can maintain what we will be doing is, let's suppose we make a hash map, and here we would be defining some kind of a new number. Okay, the new number would be, this would be actually working as a new number dot count. Okay, so this count is actually the frequency, that what is the frequency of this particular element, that there could be duplicate elements as well, like this particular 10 10 10 10 10 10, and if you need to compute for all of these tens, then you should only calculate for a particular value rather than repeating it, because if you start repeating the values, it would take a lot more time complexity. So this is why we are using this particular count to avoid the repetition point. So here it would simply be frequency, right, and a score of same new number dot steps, like the total steps over here. So I've written the steps over here. It would simply be the frequency, like the total number, into the current steps what x has taken, current steps, right? So, and after this what all numbers, when you will be iterating this final scoreboard, so you would be only considering those numbers like whose count is actually score of numbers dot count. We would only be considering those numbers whose count is actually reached to n, because then only we can say that these all n numbers converge to a particular point, right? If the scoreboard is actually equal to n, then you would go and find the minimum steps, like the, so the steps for this would have, let's suppose the steps for this particular value, this particular number is 10, and there could be the more numbers as well, which for which the steps could be 2, for which the steps could be 3. So we'll take all of those values and we will find the minimum. So this is how you would be solving this particular problem. So I hope you able to get the logic of what I am trying to say. Let me explain you this with an example as well. So let's take an example as 3, 6 and 10. Let's suppose this is an array and your n is equals to 3, right? So what we'll do is, let's start with, let's make the path for 3. So for 3 it would be going to 4, for 4 it would be going to 2, and for 2 it would be going to 1. Okay, and for this I would have taken 0 step, for here I've taken 1 step, here I've taken 2 steps, and here I've taken 3 steps. So if I'll make a scoreboard kind of thing, if I maintain the scoreboard over here, so what my scoreboard would look like, it would look like 3, 4, 2, 1. We could all reach by all get count 1, right? All get a count equal to 1, because these all are unique right now. Now let's go for 6, right? For 6 we have 0 steps, for 6 to 3 we have 1 step, for 3 to 4 we will reach to, from 3 to 4 we would be having 2, for 2 again we would be having 3, and for 1 we would be having 4, right? And now how would your scoreboard look like? Scoreboard would look something like 3, 4, 2, 1. So this all would get count as 2 because they are repeated, and for 6 the count would have been 1. Count is actually equal to 1, right? Now same will process for 10. For 10 I'll go to 5, for 5 I'll go to 6, then 3, then 4, then 2, then 1, right? So if I update my scoreboard over here, for 10 and 5 my count would be 1, count equal to 1. For 6 the count would be 2, count would have been updated to 2, and for 3, 4, 2 and 1 the count would have been updated to 3. Now what are the final checks? Now here we have computed all of the possible counts, right? We have iterated all of the elements, right? So what would be the final case? What we will be iterating over? We'll iterate over all those elements and we'll check whose count is equal to n. So only 3, 4, 2, 1 count is equal to n. So we'll consider 3, 4, 2, 1, right? And what we'll be checking is what is the minimum number of steps for each to reach at 3, 4 and 2 or 1. Okay. So at So if we take at target 3, at target, if we assume that we want to reach 3, so from 3, like we would, from 3 what I'll be requiring is 0 steps, right? From 6, how many steps would I be requiring? Like the array was 3, 6 and 10, right? So from 3 to 3, how many steps I'll need? 0. From 6 to 3, how many are required? 1, right? And from 10, how many would I require? I would be requiring 3 steps. So here in total there would be 4 steps, right? So here in total would be 4 steps I would be doing. Similarly, I will go and check for 4, right? For target 4, so from 3, if I have to go, I would be requiring 1 step. From 6, I would be requiring 2 steps, and from 10, I would be requiring 4 steps. So here the answer would have been 7, right? And I'll go and check for 2 as well. For 2, I would be requiring 2 steps for this, 3 for this, and for 10, I would be needing 5. So there here would be 10 steps. And to reach 1, what would be the steps? It would be 3 for this, 4 for this, 6 for this. Yeah, so and it would, I'll end up to 13. So out of all those steps, which is the minimum, 4. So our target would be 3. So we could all reach 3, and the total minimum operations required would be 4. So if I show you the code as well of what code I've written, like here I've faced the time complexity because I was using a normal hash map over the unordered hash map. So unordered hash map is better to reduce the time complexity, and so that's why I use that. And also I was using some kind of a set over here to find whether the particular number is being repeated or not. So to avoid that, because iterating the set was also taking a bit of a time, like a lot more of time, so I've used some kind of a, I'll actually maintain the path over here, because if you see, to reduce 10 is to power 9, 10 is to power 9 to actually by 1 using like the 2 by 2 by 2 by 2, so it would actually take log n time. So that won't, like, not log n time, this would actually reduce to, like, this would take up very less operations in terms of iterating over the set for each of those elements. So that's why I've taken the path. So it would actually roughly falls around 60 operations. So that's why I've taken the path over here, and I'm checking for each of the path. And here the same thing I'm using, I'm updating my store as well for each of the value, and current is also updating. And finally I'm checking if the RC is equal to n, and for each of them what is the total number of steps, minimum steps required. So this is how I was able to solve all of those ABC problems. So as I mentioned that there would be a surprise which I have planned for the end of this video. So the surprise is that what I'm thinking of is to start a playlist, right? A playlist in terms of a DSA tricks or something which you would be helpful in terms of I would say interviews and all of those that I'm being giving the OS much more today. So I would be picking all of those questions and interviews questions, so to help you that which questions are being asked, how to make them quickly, a 2 to 3 minute video for each of the question. So just let me know whether this would be helpful for you in the comment section, and what all questions do you want me to add in that, and what all things you want me to cover as well in this YouTube channel. So I would be covering them completely, like a kind of a playlist or a kind of a series you want from me. I would be covering all of this from interview point of view, from DSA point of view. I would be covering all of this. Just let me know in the comment section, and also just start solving and solve more and more questions. Then only you will be able to solve A, B, C, D, E. Yeah. So thank you guys. Thank you everyone.